Giles Heron. I met Giles at one of the Cisco Live DevNet Zone areas, and then like a puppy, I've kind of followed him around all sorts of other summits, Open Network Summit, OpenDaylight Summit, OpenStack, and listened to many of his presentations. He's very knowledgeable on OpenDaylight. I believe he works in that OpenDaylight group in Cisco, because Cisco also offers OpenDaylight as one of their products. So without any further ado, I'm going to turn it over to Giles. Take it away, sir. You have the floor.
Thanks, Bo. Yeah, first off, I hope everybody can hear me okay. My apologies for the rather unusual background here. As you can probably guess, it's about 1 o'clock in the morning here, so I'm doing this from my study at home rather than from an office. So let's get some slide sharing. That's a pretty good way to start, isn't it?
We're still sharing the wrong slides.
No, that's okay. Oh yeah, I need the ball, don't I?
Yep.
Yeah, that's it. Right. Okay, PowerPoint. So hopefully you have this now. So yeah, I wanted to talk about software-defined networks, and particularly in context of OpenDaylight. But I guess where I really want to get to is talking about this kind of new concept that really OpenDaylight has introduced of model-defined networks. So really looking at what do we mean for a software platform to be model-defined, to be model-driven. You know, what are the advantages that gives us, and particularly how does that play out in the networking space? As Bo said, I've been working with OpenDaylight at Cisco for a while. My background, though, like probably most of you there, is actually from the network's point of view. So I started out, in fact, as a software developer a long time ago now, as you can probably see from my gray hair. But around, I don't know, 21, 22 years ago, I was living down in New Zealand and working for a telco down there, doing internal IT stuff. And that was the point where the whole sort of commercial internet boom happened. And I somehow got to be the person who built the network there. That was the first network I'd ever built. But bearing in mind it was New Zealand and we only had, whatever it was, 4 million people and 60 million sheep, the network wasn't as big as it might be in the US. So I started out, I think, with a couple of thousand dial-up ports on Ascend Max 4000, if anyone remembers those boxes, with a few Cisco 4500s. That's going back some as the routers. And from there, I've really been doing networks ever since. What's been interesting the last couple of years is this whole SDN space and around OpenDaylight, and how I guess I've started to come back more to the software side of my background and try and put the two together. I think in context of SDN, the first thing to say is that you probably all know this Gartner hype cycle. Well, SDN is pretty much as low on this hype cycle as it can go at this point. In fact, you can see here this was like a year and a half ago, and it was already almost at the trough. So really the hype is over. So the question then is, okay, you get through that peak, you go through the trough, you come out the other side. Well, what's real? So I guess I want to look at what's real. So SDN, initially, if you look at the guys at Stanford who started all of this off, it was very much defined in terms of control and data plane separation. So what they meant by that was that if you look at a Cisco router, it has a control plane and it has a data plane. So you're running control protocols. So whether it's OSPF, BGP, ISIS, RIP even, to distribute routes through the network. But the data plane then is the IPv4 or IPv6 or MPLS forwarding that you have running on that router. And I guess the realization these Stanford guys had was, well, those two things are quite tightly coupled in a router. And Cisco obviously will sell you this box, which does these functions, but they won't uncouple the forwarding from the control plane. So you can't buy just the Cisco forwarding plane or just the Cisco control plane typically. You buy the whole router with everything in. So what they wanted to do was separate the two, and the technology they came out with to do that was OpenFlow. So the idea being that you have something that very much emulates the TCAMs that you typically have in a switch or a router. So the TCAM is the memory that lets you do things like ACL lookups. So typically, you can do a match on multiple fields. You can do longest prefix match. And so what they were saying was, well, could you have a protocol that lets you program those TCAMs, and then the switching element simply has to implement that protocol, and then all of those control plane protocols and concepts can run in a logically centralized position in an SDN controller or a set of controllers. And really where those guys were driving at, if you go back, was to say, well, Cisco, sell me that router, but it's kind of expensive, and could I buy a cheap off-the-shelf switch instead? I guess as an aside, having come at this from the background of working for service providers, so my most recent job before Cisco, I was working for British Telecom, looking after network architecture for them on an end-to-end basis. And the challenge, I guess, when you started to look at where the money actually went, was that much more of it in a carrier typically goes on your OSS, so your operational systems, than goes on the routers themselves. So I would contend that focusing on cutting the cost of your network elements as a carrier is probably the wrong focus. Where you should be focused is on cutting the cost of your operations and making it easier for software developers to write systems that provision customers in the network, that manage the network, and that sort of thing. And I think where we come to on that is that if you look at modern network elements, they have a vast amount of counters in the hardware. So typically, you'll have a forwarding ASIC, and it will have thousands or even millions of different counters that you can poll. They can give you information about everything from how many packets per second you have for each different flow, but also on the router you have even the environmental information. There's an awful lot of information out there. If you can somehow gather that information and then provide interfaces for developers to make state changes in the network, then maybe that gives you a much more programmable network than we've had up to now. And so really that's where we see the benefit here, is that this is all about network programmability. Of course, the challenge, I guess, for an audience of, I'm assuming, largely networking people, with Cisco certifications who are used to typing on CLI, the question then is, well, how do I go from being somebody who drives CLI to being somebody who programs the network? The good news there, I would say, is that a lot of software developers may have the programming skills, but they don't have the domain expertise, and that's what we as network engineers bring. And actually, the learning curve into doing basic programming with languages like Python really isn't too hard. And a lot of actually what we're looking to do here, I can show some demos as I talk today, we can drive a lot of that from tools like Postman, which is simply a tool for exercising REST APIs, which fundamentally are based on the web. And I guess we all use web browsers in our day-to-day work. So things like URLs are very well understood by everybody. So my broader definition of SDN would be that it's all about harvesting this information that we have in the network, and then it's about programming the network to optimize the user experience. And often we see this sort of loop where we learn some information and then we program some information. And really, where I often see the most value in network-facing applications is where we're, instead of just using, say, OpenFlow, we're actually looking to use multiple different protocols. So we might be using BGP-LS, so link state additions to BGP, to learn information about the network, and then we might be using PSEP to program label switch paths through the network. So you often see that dual mode where you're learning with one protocol and programming with another. And I can give examples of that. And that's something actually at this point I should say, if you do have questions, just throw them in, because certainly particularly at 1 o'clock in the morning, it's good to know that your audience is awake, or hopefully more awake than I am. So Bo mentioned that Cisco's been very involved with OpenDaylight, and really where this came from was that we as Cisco were seeing this whole SDN move and saying, well, what should an SDN controller look like? What should a platform for deploying network applications be? And really, in the end, to me, you come down to these 3 layers of functionality. And perhaps, we didn't figure this out from the start, but it's clear now that there are at least 3 layers of functionality we want a controller to give us, an SDN controller. So the first thing is having what I call these developer-friendly APIs for network elements. And what that comes down to is having something that a web developer, who's probably half the age of many of you in the room and certainly half of my age at best, I won't comment as a fraction of Bo's age because I want them to talk to me. It really comes down to things that they understand and that they love. And very often, that's going to be these REST and JSON APIs because that's the kind of new world of web applications. And so can we provide those sort of interfaces so that people can program the network elements? And in fact, what we're seeing is that a lot of those interfaces are even making their way onto network elements themselves. So you're now finding routers actually having these REST APIs on them. But very often there's value in having a controller as a point of control where you can talk to all the different routers through one controller. But having said that, that's a start and that's great because now a web developer can access a router without having to pretend that he's typing in a telnet session, which isn't something these guys typically understand. But really the real value and power, to my mind, comes from having network-level abstractions, because once you've got a controller that can see all of the network, can we now have abstractions that let you operate on a network as a whole instead of on individual devices? And even better, then can we raise it one layer to say, well, can we now be a bit protocol independent? So can we write applications that think in terms of, for example, a network topology, and they do that without being too concerned about where that topology came from? So, from an IP point of view, we might say, well, I don't want to really care whether I'm running ISRS or OSPF as my link state protocol. I just want to operate on a layer 3 topology. But it could even be you have a topology that's a layer 2 topology, or there's an open flow topology, and you just want to write a topology application that understands and can draw pictures of topologies and that sort of thing. So one thing about this is, I did mention OpenFlow briefly in talking about it as a type of topology, but really, that's not our focus in terms of OpenDaylight. So I think it's often easy to mischaracterize it as an OpenFlow controller, and I certainly heard that even inside Cisco. Really what it is a platform for developing SDN or network applications, and it provides a development environment for doing that. I should probably briefly say, of course, this is Cisco, and as usual, we have more than one horse in the race. So we have done a lot of the work on OpenDaylight. There are other control platforms from Cisco, so you may have come across APIC EM. You may also have come across the whole APIC ACI platform from the Nexus 9K world, and I noticed there was an announcement today about Titration version 2, their analytics platform. That's not what I'll be speaking about, and I guess I'm not the expert for that stuff. The way I perhaps would characterize it is that OpenDaylight, being an open source platform, a lot of its sort of sweet spot so far has tended to be in academia and in service providers, perhaps rather than enterprises. And maybe those other platforms are more likely what you'll see in enterprises. And the difference really being that a large service provider is possibly more willing to do their own development work, to customize the platform to their own needs. And often what you find with the large service providers is they're very keen that platforms they deploy are open source. Whereas, as an enterprise, you're more likely to want something you can take and use off the shelf. So I've talked about a platform for developing network applications. Well, clearly what we want is flexibility to have a range of applications. We want this to be something of a Swiss Army knife rather than a single function tool. And we want to do that in a way that's consistent so that you can develop applications in different domains using consistent models. And we want it to scale in terms of both development so that you don't have hotspots in your code where there's one critical piece of code that only one person understands. But then also, of course, we want runtime scalability and horizontal scaling, the usual thing people talk about in this space with, initially we're doing clustering very much around resiliency, and the classic kind of 3-node cluster where the nodes vote, and if one node can't see the other 2 nodes, it declares itself no longer in the cluster. But long term, what you want is to scale clusters horizontally to much larger numbers of nodes. And that's, I guess, just the reality of where we're going with, more CPU cores and, not so much speed in one CPU, and certainly with, the more scalable data center approach, where instead of building one giant mainframe, you deploy large numbers of smaller servers. The key thing there also is this runtime modularity, and I guess I'll show that, how we can load new plugins at runtime, and then we can learn new information about the network at runtime, even down to learning, a device we've never seen before, understanding what capabilities that device has, and being able to use those capabilities at runtime. And to do that, we need a domain-specific language, which is focused on having data models that describe networking entities, so very much around things like network configuration. So we have this language called Yang, which we'll come on to later, which is a data modeling language, and you can describe the config of a router in Yang, and that's really what it was designed for. But it turns out we can then extend it to lots of other things. And then we want tools that are aligned with Yang, so the controller itself will very much use Yang all the way through. Another thing that's worth mentioning, and I guess we'll come on to it again, another platform from Cisco you may have heard of is NSO, which came from the TLF acquisition. That's also very much a Yang-driven platform. The difference, as I would characterize it, is that that's very much around orchestration and configuration. OpenDaylight is more of a network application development environment. So yes, you can use it in configuration, but you can also use it for much more sort of control plane interaction. So I'll do some stuff later around BGP. I'll show some slides and probably show some demo around how we can interact with BGP. And the key thing is we want to generate code from these models and generate APIs from the models, so that as we enhance the controller, as we discover new network elements, we don't want to keep having to enhance the APIs manually and write new code. We want that boilerplate code to be written automatically for us. So how does that pan out with OpenDaylight? I should say I've divided this into sections, so we're about, I guess, 20% of the way through. What I'll do is divide it into sections, and I'll say at any point, if you've got questions, do feel free to ask. So this is the eye chart, just to see how good the screen is down there in Dallas-Fort Worth.
Nowhere near good.
Yeah, it gets more and more like an eye chart with each release of OpenDaylight, I'm afraid, because you can possibly see towards the bottom we have the network elements. Then we have a whole layer where we have the different plugins, protocol plugins that we can use to talk to the network. And I guess this speaks back to what I said about, it's not just OpenFlow. So we have OpenFlow, we have OFConfig, OVSDB, NetConf, and so on and so on. And every new release of OpenDaylight adds new southbound plugins. We then have this model-driven abstraction layer that sits really in the middle of all the communications within OpenDaylight. And then on top of it, we have different network functions, different network services, different abstractions, which again are all driven with Yang models. And so, for example, one of the classic SDN controller applications that you'll see in the world of OpenFlow is a layer 2 switch application where, I may skip on a slide, where a controller can configure a set of OpenFlow switches and make them all appear to be one giant layer 2 learning switch. And so that, for example, is an application inside OpenDaylight. And then northbound, we have the different northbound APIs. The one we most often talk about is RESTCONF, and I'll come on to that, but we also have NetConf. We have some hand-coded REST APIs for things like OpenStack Neutron. We're also looking now to deploy more message bus kind of APIs. So we have AMQP. There's also some work being done on Kafka. And then we have various toolkits for things like GUIs on top of that. So you can see it's a pretty big platform from the scope of the eye chart. And I can't remember the numbers on lines of code, but they may be later in the deck. But we're certainly into the millions at this point. There are 2.5 million lines of code. mostly written in Java. There are over 600 contributors to this. I am one of them, but I have to say I haven't written all that much code. I've really focused more on testing and more on using OpenDaylight to solve customer problems, given I'm more of an ex-programmer than a programmer. It's all being driven by, as a Linux Foundation project. The code is all open source and released under an Eclipse license. And what happens is that companies are involved in OpenDaylight. As with a lot of these projects, you have the sort of silver, gold, platinum sort of membership levels. And with those different membership levels, you commit to different amounts of resource to fund the development. And so Cisco's been a very active contributor to OpenDaylight. I think we're the largest, but there are many other contributors in there. So, I'll sometimes sit on calls. I think Bo was on a call that I was on the other day, and there were people from the likes of, as well as carriers like Bo, there were also people from the likes of Red Hat, Ericsson, etc. on that call. At the moment, we're at the boron release. There's a naming scheme. You can see we started with hydrogen, so we're following the periodic table. Kind of unusual for an open source project. Normally they seem to want to alliterate, or rather, go through the letters of the alphabet on a theme. So, Android with its candy, and I think OPNFV's on rivers, isn't it? I can't remember what OpenStack's on. But we've gone for the periodic table, and we're up to boron now. Carbon will be May this year. The release cadence is approximately 8 months. And so each release, you'll find there will be new plugins, new services in the controller, but of course enhancements to existing ones. I think one of the challenges with an open source project, when you compare it to a traditional vendor-developed platform, it don't really have the product management function that you would have in a vendor platform. And so, really it's any kind of open source development tends to be a bit of a case of herding cats. So finding contributors who are willing to do the work you want. I think, again, that's one of the pluses of having had this bootstrapped by the likes of Cisco and Red Hat, Ericsson, et cetera, is that the vendors who put the resource in have done the work to build that platform. And so, we can build a framework that then other people can work with. Whereas I think if you didn't have that big vendor push to get the thing off the ground, it'd be hard to get it to this point, that's for sure. One thing to say, I guess, is if you have particular requirements, things that you want, things that you need, there's nothing now to stop you proposing a new project in OpenDaylight and doing that work. All you need is the right idea and some Java developers, I guess. And we'll come on to how it's actually built. And here's the first slide on that, showing the sort of, I suppose this is a simplified version of that eye chart. So showing the Southbound plugins that I personally care about. So OpenFlow, BGP, PSEP, NETCONF. And typically, your applications will live north of the controller. I think where there are key high-performance apps you need, you may build them inside the controller. But really what goes inside the controller tends to be these, what we call the base network functions and service functions. And typically applications talk to the REST APIs northbound. But really, one thing to say is when you look at it internally and how the thing's built, there isn't really a distinction between north and south. So towards the network, towards the user, and to an extent, what's the difference? They're just different plugins that talk to external entities, and then the plugins talk to each other through this, effectively this internal message bus called the model-driven SAL. And so, really, at that point, we don't see networks or users as, in a sense, any different. They're just things that interact with the controller. But what the controller also has, of course, is this messaging infrastructure, both internally and between controllers when you're clustering. And likewise, it has a data store, which, again, can either be local to one controller or can be clustered amongst a group of controllers. But the way it's implemented, yeah, sure.
I'm sorry, would you back up a couple slides to the first one you shared there? With the one more? Yes, this one. So one of the, oh, too far, I'm sorry.
This one?
Yes, that's the one. So one of the things that I have been trying to understand, right, is that we have all of these protocols that we're using to speak with from controller to network device. NETCONF, Yang, BGPLS are kind of the most commonly quoted ones. But there's still a lot of Cisco devices out there that do not support those protocols and are probably never going to support those protocols.
Right.
Are we still into screen scraping type mode once we want to integrate those guys, or is that hardware rip and replace type deal?
I think there are different ways you can look at it. I mean, so for example, looking at BGPLS, one example I give is that if you have an existing network, you know, whether it's Cisco routers or, you know, any other vendor's equipment, if you're running OSPF or ISIS, then all you need to do is have one virtual XR instance within each IGP area, and that virtual XR instance can extract the topology information from OSPF or ISIS, because of course all nodes in one IGP area have the same picture of the network, and it can then expose that information to OpenDaylight using BGPLS. So that's one example of where we can, you know, work with legacy devices. Another thing to say, I guess, is that you know, of course, we're working on having NetConf, Yang, BGPLS, PCEP, etc., and we're working across all the different OSs within Cisco. So there's work in XR, in XC, and NXOS. So, you know, other than sort of classic iOS, I think you'll find most devices will get there eventually. In terms of the sort of classic iOS, I guess the way you could look at that would be, we do have this platform NSO, and as I say, I tend to work in this more sort of open source space, but I did do the initial integration of OpenDaylight in NSO around the time of the TLF acquisition. So what we can do is that the OpenDaylight NetConf client can talk to NSO acting as a NetConf server. And then NSO can talk CLI to devices that don't support NetConf Yang. And what NSO will do is it will render that CLI into NetConf Yang. So you avoid, effectively, it does the screen scraping for you. I mean, that's just one of, you know, many capabilities NSO has. It also does service modeling. It does network-wide transactions. But just for that sort of CLI mediation piece, you can use it. And another thing to say, I guess, on CLI mediation, and particularly around other vendors' boxes, is that the TLF team have been pushing quite hard on getting their CompD platform, which is something that they sell to device vendors rather than to operators. So it's a way of it's a management platform for network elements. And I believe they actually the basic version of CompD that's NetConf Yang only, I believe is free, so that other vendors who want to add NetConf Yang to their devices can use CompD to do that. We're also, we've worked in the open source space also with people like the OpenWRT guys who build sort of home routers to have NetConf Yang on those. There is NetConf Yang support for Linux, etc. So, I think the world's getting there slowly. But it may be in certain instances, yes, you need, either to do, to use something like NSO to proxy from NetConf Yang to CLI, or, where you want to extract a topology from a network of devices that doesn't talk BGPLS, that's where you put something like XRV in there to do that for you.
Okay. I promise I'm not taking advantage of the fact that it's 1 a.m. For questions. But when you say XRV, so one of the new trends within your high-end Cisco equipment like NCS, Nexus, is the ability to build containers and to run natively, Linux operating systems or different things like that. Is that where folks are kind of anticipating that some of these controllers are going to live, or are they saying, oh no, we want to put the controllers in another space and then we'll just use these containers to add additional data models or perform other functions?
I think it's more the latter. I think we'd still expect to see the controllers living on a UCS rather than on an NCS. But with reference to XRV, I think you do see cases where people are looking to run, back to the earlier thing about SDN and control data plane separation. I think you're starting to see cases where people want to run the control plane functionality, for example, of XR effectively as a virtual machine on a server rather than on a dedicated router. So whether that's using route reflectors, whether it's path computation, any of those kind of control plane features, I think we're tending to see a lot of people wanting to deploy those on effectively virtual machines on servers. I mean, some of that, historically has been down to, us as network operators. We haven't always been comfortable operating servers, rather than operating physical routers. So often we've ended up putting in dedicated routers to act as route reflectors, even though all they were doing was route reflection. But I think with a general trend towards NFV, I think people are getting more comfortable with that kind of model. So you might well find, for example, back to the BGPLS thing, you might well find that ODL is running on a server. There's also a virtual XR instance running on that same server that's doing the translation from OSPF to BGPLS. But you still, the other routers running OSPF are all physical devices in that context. So I think, virtualization clearly as a trend is quite tightly coupled to the whole SDN thing, although they're distinct.
Excellent, thank you.
So where are we up to? So just saying how OpenDaylight's built. So it's largely written in Java, and that was really, as I understand it, more of a pragmatic choice of saying, well, there are probably more Java developers than any other language, and so we use Java interfaces between the components. We build using Maven, which is a Java build system. I know Maven's pretty unpopular generally. There was that instance of people one guy trying to compare Maven unfavorably to his girlfriend or something. He got lots of hot water for being sexist. But, I personally struggle with Maven, but I'm sure it's as good as anything else out there. I think, the world of software development has changed a lot since I was a full-time developer. So, in the old days, it was SCCS to store your code and Make to build it, and now it's Git to get at your code and Maven to build it. But at runtime, we use Carafe, which is a dynamic container infrastructure, really, for bundles that you can load within one Java virtual machine. So features can be deployed as Carafe bundles so that you can load them on the fly. When we released ODL Hydrogen, we didn't have that, and so it was released in different sort of versions. There was a base version, a virtualization one, a service provider one that had different combinations of features. Whereas now what you do is you load the features you require at runtime. So now I want to sort of step back and look at NetConf Yang, the whole sort of NetConf Yang world in terms of the protocols with less reference perhaps directly to OpenDaylight. And really a lot of this comes from service providers who, again, as I mentioned, I'm myself an ex-service provider, and we've all really struggled with this where SNMP really didn't work out for configuration. We're using SNMP traps and syslogs for finding faults, etc. We're using SNMP polling with tools like MRTG to see the usage on our network. The OSS, BSS guys were using SNMP with commercial tools to do things like volume-based billing, whatever else it might be, to monitor the network. But it wasn't being used for configuration. And what we were using for configuration was typically CLI scripting. And a lot of this was where NMS tools weren't meeting the need. So what would happen is some bright person in the NOC would go out and write some tools on top of a terminal emulator to provision things in the network. And that ended up getting formalized. So we all wrote vast amounts of, back in the day, it was expect and Perl that most of this would be written in. And the challenge, I guess, with scripting is that if the vendor changes one little thing in the CLI, it breaks your script. And so SPs were very aware of this, and there was a workshop, going right back now to 2002, where SPs sat down and said, okay, what is it we need, and came up with these requirements ultimately for a network management protocol. And what people said was, well, we don't have well-defined protocols, we don't have well-defined data models, so we're using Telnet or SSH, we're accessing different CLIs, whether we're going to Cisco iOS, iOS XR, Junos, whatever it might be. We also, particularly with OSs like iOS, you have this problem where there's a lack of atomicity and there's an ordering problem. So I guess you'll all be aware of, used to this, the problem of, if you want to create a pseudo-wire, I'm giving myself away here as an MPLS pseudo-wire kind of guy, you first have to create the sub-interface, and then you create the pseudo-wire that references that sub-interface. So there's a certain order you have to do things in. And you can't wrap those operations into a transaction, so there's no atomic transaction where you can say, if something goes wrong, I want to roll that whole transaction back out. Where I mentioned NSO and using it for CLI mediation, as I understand it, that's really the sort of secret sauce of NSO, is it can take a CLI that doesn't have atomic transactions and that has ordering problems, and it can put sort of transactions on top of that, so that you can provision, for example, a pseudo-wire across two routers, and if anything goes wrong on either of the routers, you can roll the whole thing back out again. And that was where service providers wanted to get to, because as I mentioned earlier, so much of our CapEx was spent actually in writing the software that drove the network rather than in buying network elements. And so if we can take away all the sort of error handling problems from the developer and the tracking CLI changes problems, then developers can focus on solving the business problem, not on dealing with the idiosyncrasies of the network elements. So what we want was a transactional model, we want well-defined data models, and we want standardized protocols for accessing those data models. And so effectively, NETCONF becomes that standardized protocol. Yang defines those data models. And in terms of transactions, NETCONF has facilities in it like lock and commit and rollback, etc. So how this looks in the wild, as I call it, is you might well have an OpenDaylight controller. It's accessing a bunch of routers. Those routers will have Yang models that describe how they operate. OpenDaylight will pull those models into itself, and then through the REST API on top of OpenDaylight, you can access the routers using those Yang models. This might be time for a demo. In classic fashion, I haven't actually run through this beforehand, so we'll see what happens. So if I think I'm on this one, right, great. Just to check my NETCONF sessions up, you can see that it is. NETCONF typically runs over port 830.
Giles, you're not sharing it.
I'm not sharing it, you're right. Okay, so you should be able to see that I have a session up and running. What on earth McAfee are doing on my machine, I don't know, and probably shouldn't know. And you can then, if I go into, I mentioned Postman as a tool for looking at REST APIs. So let's look at Postman then. And if I go to this particular instance of the controller.
Can you maximize that screen?
Maximize, yeah, sure. You can now see.
Way better. Yeah, thank you.
These fonts are pretty painful, but you can see here, for example, this is ODL and its own config subsystem, but now you can see that it's mounted an ASR 9K, and here are all the different capabilities that 9K supports, and these correspond to individual Yang models that are supported by that ASR 9000. And so now we can access them. So for example, here are the interfaces on that individual router. And so you can see them here being rendered as JSON. But this is very much the same information you would get from the CLI. So if I quickly unmaximize just to prove that, if I quickly go to CLI on that router,
Again, if you can maximize that screen, that would be helpful.
Oh yeah, sure.
Yeah.
Bit of luck. You can see that's the same. That should be the same information in terms of addresses and use the word foobar as you're seeing in the other one. So effectively, so come back to the slides. What's happening there is that I'm accessing that REST API on OpenDaylight. it's then using NetConf to talk to the router, and then it's extracting that information from the router. And so if we were to come back to my earlier point about what were the requirements from the controller, this kind of meets that developer-friendly API, because now you can see that data is being rendered in JSON through a web interface. And in fact, although I used our friendly Postman there, the interesting thing, if I share Chrome, this is where you get to see how long the URLs are. Got to remember the address of my controller now. It's going to be this guy, I suspect. Let's go, Luke. Right. Yes, don't want to talk amongst yourselves while I type.
I find it funny that your most visited page is Facebook.
Of course, in the brave new world, you'll have all of this stuff memorized. You'll just be able to whip it right out across the URL box there.
Yeah, and it won't even talk to me. Probably if I'm putting the wrong address in. It's probably I think it might be the 12701.
So that IDE you were using a moment ago, that's Postman Builder?
It's now going to refuse to work for me, isn't it? I was using Postman normally. Whoops, change the screen angle.
So you had a question about Postman. Was that an IDE or what exactly was the Postman?
Yeah, so what Postman is, I've lost it now. So Postman really, in fact, it's actually built on top of Chrome. So it comes from Google, and it's just a tool for accessing RESTful APIs. And what it is that when you're using a browser, all you can do is get. And also, you don't have the flexibility to set your HTTP headers. With Postman, you can do all the different operations that are defined in HTTP. You can set whatever headers you need. And then, of course, you can store all of these and store them in collections. So I have a bunch of this stuff stored in GitHub. So I mentioned Git earlier. I have a whole bunch of collections, in fact, these same ones you see down the left, that are stored in GitHub, so you can download those and play with them. I'm wondering how I've broken communication with my controller, but let's not worry about that for now.
Giles, this might be a good time to mention to the people here that if they're not aware of it, Cisco has a thing called the DevNet Learning Zone. It has several lessons. The DevNet Learning Zone is free to sign up for, and one of the very first things is something called, I think it's Programming for Network Engineers, and one of the very first things that it goes into is making use of REST calls to access different things, and there's introductions to what is Postman. I think there's stuff there on Git. It's a wealth of information that I'd highly recommend that you take a look at.
Yeah, thanks for the plug. So we, I would say that, it's definitely worth going on to DevNet Zone, particularly, both the online stuff, but particularly if you get to a Cisco Live. We have I doubt many people there will be going to it, but we have the Cisco Live in Berlin happening in a couple of weeks' time. I think the summer one is Las Vegas. And so there's, at Cisco Live, there's a whole bunch of hands-on labs and talks and things. Okay, I'm obviously using the wrong address to talk to my controller there, so I'll ignore that and move on. So really, the way to look at this is that in NetConf Yang, like anything in networks, we talk about layers in terms of, the good old-fashioned OSI model. Well, let's not worry too much about naming layers and how many layers we have, but in terms of NetConf, fundamentally, it typically rides on top of SSH, to give you the secure encryption. It's fundamentally based on XML RPCs, and so you can model things in Yang as RPCs and actually get, have RPC operations on your data more often what you see is a NetConf operation like edit config, get config, etc., which will then be wrapped up in an RPC. The data that's carried is XML, but the definition of that data is in the Yang model. The one thing to remember with NetConf is that your server is your client and your router is your server, sort of thing. So the OpenDaylight would be a client, and it would be talking to a NetConf server that would be running on a router. Another thing to remember is that just as on XR, you can edit a config and then eventually type commit. This is kind of how it's running in NetConf. You can have multiple data stores. So you can have your running config, your startup config. You can have candidate configs, which is where you're editing one and haven't committed it yet. NetConf gives you the flexibility to choose which data store you're operating on. When we come to RESTCONF, I guess we'll see that with RESTCONF, we don't have that degree of flexibility. So what we lose in flexibility, though, we'll gain in terms of REST API. So this was defined originally in RFC 4741. The latest is RFC 6241. The first one was written before Yang came out, and that's where the new RFC was updated. One key thing is NetConf doesn't define the content. That's defined through Yang models. It's probably worth mentioning briefly that we have had NetConf implementations on Cisco boxes for a while which didn't support Yang, and it's only now in the last few years that Yang's being introduced. The problem from a sort of controller perspective, if you're using the older implementations, is that you can send a bunch of XML to a device and get a response back, but you as the developer still have to parse that XML and understand what it means. The great thing once we're working with Yang models is that the controller takes care of that for you. I mentioned also, the fact that we have things like commit and lock and rollback. And as for vendor support, yes, we implement this on multiple platforms in Cisco, but also if you go to your other vendors, you'll find now that most of them support NetConf Yang.
Giles, obviously this is associated with configuration because it says NetConf and RESTCONF, but I get the impression that some of the Yang data models are beginning to define some of the operational information in the router, such that if a lot of the various show commands that you would do from a CLI are becoming available as a Yang data model that can be extracted with one of these tools.
Exactly, they are. Yeah, and so typically, for example, in XR, we have two types of models, config and operational models, and they'll end with -config or -opper, depending on the type of model. And I guess the focus initially was on config because that was where SNMP had failed. And in many ways, the opper models just replicate what we already have with SNMP. I think the interesting thing, and I'll come to that later, is the whole operational model really needs to shift away from being about polling devices to get information to a model where the device sends you the information proactively. And so that's, I think, we're seeing this move towards things like streaming telemetry and XR. And in terms of platforms, that's where we're seeing the shift to things like Panda, which is a pnda.io. You can look that one up online. It's an open source telemetry platform that Cisco's developed, well, analytics platform that Cisco's developed. The PNDA stands for Platform for Network Data Analytics. And the model there is that devices will proactively send you this information, whether it's event-based or whether it's something that they send on a timer. And so instead of polling devices for information, the devices will ship it off into an analytics platform where you can then start to analyze that data and then take action. And that's where we get into this sort of brave new world of machine learning and AI kind of stuff that I have to confess I don't really understand. But yes, definitely we need to move beyond just configuration, and that will be a good segue to later on. So the RESTCONF, as I mentioned, it's an alternative to NetConf. It uses REST instead of SSH. We can use JSON instead of XML. So that example I showed was JSON. And really it's much more developer friendly because developers tend to prefer JSON to XML these days. In fact, this slide I should have updated. It says almost an RFC now. It is actually an RFC. It was issued, I think, yesterday. It's RFC 8040. and RESTCONF supports notifications now using, I think SSE stands for server-sent events. That was one of the initial challenges we had, was that in RESTCONF, you always had to poll. There was no way to send a notification. And as I mentioned, really we want the whole management model to move away from polling to a more notification-based model. So Yang is really just the data models that we stick on top of RESTCONF or NETCONF. And it's very much analogous to having an XML schema or to the SMI that we use in SNMP. The thing with Yang, though, is it describes the data, it isn't the data. So Yang itself, a Yang model, looks rather more like a C program than it does like XML or JSON. And yeah, we use it to model config, operational, as we've just been talking about, notifications I mentioned, but also, as I think I said earlier, you can actually define RPCs in Yang. That's been one of the challenges. You can define an RPC, for example, that says, ping this router and see if you get a response. The challenge is that we don't really have the primitives to have, from the CLI, you might do a ping and then you get response coming gradually. And there's still a bit of a debate about how we do those kind of things. One of the things that NETCONF has is constraints on the data. So you can have things like musts, where you say, if I have a pseudo wire, there must be 2 endpoints, as an example, if you have a list of endpoints there. But in many ways, if you look at, as I said, it looks a bit like C code. And in many ways, somebody like myself from a programming background, I look at a Yang model, and it looks a bit like the sort of C header files we used to have, defining data structures and things. So it assumes that you're going to encode in XML, and that's something that's changing now with Yang 1.1, is we're trying to move away from that tight coupling to XML. But there's still some sort of XML things embedded in there in terms of, we use XPaths, which is an XML construct, to find paths to data items in the tree, and that sort of thing. But we're trying to move beyond, as I say, beyond XML, not just for RESTCONF, which can be JSON, but also, as we move into this world of telemetry, the assumption is that we'll be sending Yang model notifications, but we'll probably be encoding them in something like gRPC, which is Google's RPC mechanism. And so, in the NETCONF world, you can see we have our Yang models, we encode in XML, and then we have that defined NETCONF stack of get config, edit config operations, running over XML RPCs, running over, for example, SSH. With RESTCONF, we add the web world of HTTP, but we also add JSON encoding. But then, I2RS is the working group doing this in the ITF, looking at things like telemetry and like ephemeral configuration. And my guess is gRPC is the kind of protocol people will use there, because they'll want a more efficient binary encoding. But in fact, OpenDaylight itself uses Yang to define the interfaces between different components in ODL. So effectively, it's using it as an interface descriptor language. And it's just passing around Java data transfer objects rather than anything that's XML or JSON encoded. Because we're internal to the system, so there's no need to serialize the data for putting it out on the wire. We're operating, within memory.
Don, you might mention what you talked about NSO and ODL and some of these other things, but a lot of people in the room might not be familiar with what the I2RS working group is doing and what that is intended to do as a protocol.
If only I knew the answer to that, Bo. So the I2RS working group is covering a few different things. I think where it came from was a realization that there was some value in OpenFlow, and a realization that this kind of more dynamic model for a controller talking to network elements was a good idea. And then looking at it, stepping back from an IETF perspective and saying, well, do we really want to interact with the FIB, which is effectively what OpenFlow does, or wouldn't it be better to interact with the RIB? And don't we want to be able to do things like push static routes into routers at high speed and that sort of thing? So that was where I2RS came from, with the concept of an ephemeral data store for NETCONF. I think it's now the scope has expanded some way beyond that. So, for example, the topology models I'll come on to are now within I2RS. A lot of work's also been done in I2RS on things like traceability and user authentication, where if I'm using a controller to configure the network, or if a specific application is using a controller to configure the network. Today on the router, all you would know is that the controller has configured the router. Really, you need to know which application or which user was behind that controller when it configured the router. So those sort of things are key to I2RS as well. So it has made it quite a large working group, and there's quite tricky interactions then between that working group and the NetMod working group that defines Yang. I think it's also true that I2RS sees itself as a big user of this whole telemetry model, where binary encoded notifications might be sent out by the network. Because I think we realized early on with I2RS that if we had an ephemeral data store, and if we were making very rapid config changes on the network, which the ephemeral data store will allow us to do, I'm getting a warning here about video not working, so I hope you can still see me, but I can't see you guys.
We're still good. Yeah, it's on our end.
Okay. Oh, this is the 7 p.m. outage you mentioned happening an hour late. Okay. I thought it was my cable company doing maintenance again. Yeah, so if you want to make changes, normally when you can change configuration, the issue is it's quite slow because you have to do all sorts of checking on the validity of the configuration, and then you have to store it to flash. You typically, with dual RPs, you have to copy it to the redundant RP, that sort of thing. In a world where you're making fast ephemeral changes, you don't want to do that. And so if you can bypass a lot of that checking, if you only store it to RAM on the active route processor, you can then make changes much faster. Once that's the case, then you start saying, well, what's the next bottleneck? And that's where people have looked at things like gRPC as being more efficient than using XML encoding over SSH, for example. And I think particularly when you come to telemetry, and you might be shipping off large amounts of data that have come from the ASICs, as I mentioned earlier, that's again where you need a more efficient binary encoding. And I think people also want to be able to do things asynchronously, because again, the NetConf model is very synchronous, it's very transactional. You only make one change at a time to the router configuration, and that's probably anathema in a world where you're making very rapid changes and you have multiple applications running. So that's the goal of I2RS. I mean, it's been running for, I think, 4.5 years now, so it's time for some RFCs to emerge, and I think 1 or 2 are starting to come through now.
The summary to that answer is it got its start with the idea of pushing routes directly into the router from the controller, and
yeah,
obviously it's blown up from there.
Exactly. We started thinking in terms of like static routes and ACL entries, and it's kind of grown out from there.
We got another question in the room.
So sure. What's the difference between OpenDaylight and Cisco ACI? Did you mention that?
Yeah, I guess I was saying earlier, I'm probably the wrong guy to ask about that to some extent. I mean, the way I would characterize it is that, ACI is, as I understand it, quite tightly integrated to the Nexus 9K platform. And so really it's very much around, if you have a data center with Nexus 9Ks, here's ACI, which is a plug-and-play controller to drive that network. And a lot of the focus from those guys has been on intent, which I'll come on to in a bit. So the idea of saying, well, OpenFlow lets you say, I want to set up a flow through my network. But actually, really what you want to think about is intent and policy, and saying, I don't want users in the HR department accessing a server that belongs to engineering or vice versa. And I think that's really where ACI is targeted from what I can tell. There's also this other platform, APIC-EM, which is a kind of enterprise-focused controller, but it's not tied to sort of the Nexus 9K data center kind of play. Whereas OpenDaylight, much more, it's multi-vendor, it's open source, and it's very much, in service providers and academia that we've seen the deployment. I haven't seen many enterprises deploying it at this point. They might do, and I think in order for that to happen, you either need an enterprise that's willing to write code, because out of the box, OpenDaylight really gives you a toolkit and a framework, or it might be that vendors start selling pre-integrated solutions based on OpenDaylight that enterprises can then deploy. And we've seen that a lot of vendors are selling OpenDaylight, so they're taking, and it's a bit like the Linux model where you can download Linux for free, or you can buy it from Red Hat or Canonical. The same kind of model is happening with OpenDaylight. So in a sense, it's not that surprising that people like Red Hat are actually involved in OpenDaylight. You can see the parallels in the model. This was just a picture to say what does the Yang model look like, what it looks, kind of like a C program or a Java program with lots of curly brackets and semicolons. The key thing here, you can see I took that screenshot from my text editor, Sublime Text, and what you find is most decent text editors will do all the cool syntax highlighting for you so you can understand your model as you work with it. And that's one thing that, a lot of work's been done now on tooling behind OpenDaylight. So, behind Yang. So having tools to check Yang models, to validate Yang models, that sort of thing. So I showed you earlier, looking at an interface on a router with NETCONF. How this actually happens at runtime before you even look at the interface is that you add the node in OpenDaylight typically by using the config subsystem from REST. OpenDaylight connects the node gets into ODL's inventory, and then it pulls in the data models, the Yang models that node supports one by one and puts them in a cache. What happens when you connect to another node, if it's running the same release of the same OS, what you'd expect to see is no more changes to the cache because it will have the same models. But when you connect to another device, then you'll find that, of a different type, then there'll be new entries in the cache. And those files in the cache are just stored on the server that you run OpenDaylight on, so you can log on there and see the models and edit them, etc. If you're interested. So I wanted to quickly shift gears and say, well, okay, as Bo was saying, this is all about configuration. Well, what about other stuff? So one thing I can quickly go through is, how does this apply to BGP? Well, OpenDaylight, as I mentioned earlier, has BGP and PSEP plugins. PSEP is just a protocol for doing path computation and then pushing those paths into the network. So instead of the router figuring out the best path through the network, it asks the controller, and then the controller computes that path. And this is really where the concept of topology starts coming in. OpenDaylight will learn the network topology using BGP-LS, so the link state address family on BGP, but then it will push paths in using PSEP. And having implemented that for BGP link state, what ODL then did was implement a lot of other address families. Because really, to implement an address family in BGP is pretty straightforward in terms of just adding new TLVs, new type length value fields, and knowing how to decode them. So link state routes we get from IFS or OSPF, and we use them to get a network topology. But we also now can learn, IPv4 and v6 unicast, labeled unicast, flow spec, which is in a sense, I mentioned I2RS being kind of an equivalent to OpenFlow. Well, in some ways, flow spec is also an equivalent to OpenFlow in that it's saying we can encode match action entries using BGP communities and distribute them through the route reflector infrastructure. And we've seen a lot of interest in flow spec in areas like DDoS mitigation. Now might be a reasonable time to mention, if you want to... Sorry, was someone asking a question there?
Nope.
Oh, sorry. It might be a good time to say, if anyone's interested in more sort of information on that, a lot of this stuff is covered on various videos and presentations that I've done at things like ODL Summits and Cisco Live, so you can dig those out of things like YouTube. We now, as of the Boron release, also support V4 and V6 unicast VPN routes, so traditional IPVPN, but also EVPN. I think EVPN is particularly interesting in the data center context, where you do use EVPN as a control plane for VXLAN. And what ODL does is it implements the normal sort of BGP chain where you have, for each peer, you have an adjacent ribbon, which is all the routes you learn. You have an effective ribbon, which is all the routes you've learned and effectively accepted based on your policy. At the moment, the import policy is fixed, but we are adding policy knobs to let you modify the policy. I think one thing that's worth saying is actually in a controller, a lot of your flexibility comes not from things like configurable policies, but from the fact that you can create multiple instances of the RIB and you can string them together using any pipeline you choose, really. Whereas from the REST APIs, if I want to advertise a route, I have to use this special RIB called the application RIB. From Java code, I can interface to any of these kind of hops in the, oops, sorry, see my hand on the screen. I can interface with any of these kind of hops in the chain. And so, yeah, I can spin up as many RIBs as I want. I can ignore certain types of route, that sort of thing. And so what we then do is we use normal BGP best path selection to generate a local RIB. And then also for each peer, we have an adjacent RIB out, which again is pretty normal in a router. But from that RIB, we then generate topology. And as I say, link state topology is a key one because it gives us sort of a map of an IGP network. But for V4 and V6, we also generate topologies, although there are no links in those. They're really just lists of BGP next hops, and for each next hop, a list of all the routes.
Speaking of topologies, OpenDaylight has a pretty nifty little tool that actually draws out topologies of various things. This is a little bit of a side question. As a programmer, isn't that a standard off-the-shelf package that they use to actually generate those nice little diagrams? What's the name of that?
Yeah, actually, we used a tool called the NextUI toolkit, which is something also that was developed in Cisco and is now open source. And we basically had one of my colleagues wrote some Python code that talks to OpenDaylight. It then effectively modifies the topology it gets from OpenDaylight into a form that NextUI will use. NextUI is written in JavaScript and just runs in the browser. And so it then just presents that through the browser. And again, in some of those videos on YouTube, you can see examples of me driving that application. What I thought would be quickly worth showing would just be the, let's go to a router that's connected, or a controller that's connected with BGP. So we'll find my BGP collection. Where is it? It'll be further up probably. Oh, here you go.
Did you sacrifice again as to the demo gods?
Yeah, exactly. So you can see some BGP routes here. And again, this is back to what I mentioned about kind of, developer-friendly APIs. You can now see this in JSON. You can see the information here. Here's the route. Here's the next hop. But this is still very much semantically, this is a BGP route. You've got things like origin, med, AS path, local pref, etc. Whereas once you look at the topology view, and as I mentioned, the V4 topology doesn't really have links in it. It just has next hops, and for those next hops, it has the prefixes they're advertising. You now don't have to see that that kind of BGP-specific information. You're just seeing the routing information. And where that becomes more important, I guess, is for link state, where we just want a topology of our network. So really, a lot of this stuff around AS paths and next hops, isn't that important when what we want to do is draw a picture of a network. And so from those link state routes, we generate a link state topology. And the topology you can see is just a list of links and a list of nodes. And in this network, I've got two routers, so you should see there are two nodes. And so they're both ASR 9Ks. Each node, you can see the IGP prefixes associated with it. And then there are two links, because I've got a link between the routers, but in the BGPLS topology, links are unidirectional, and that's because we may have different metrics in the different directions and different bandwidth assignments in the different directions. And so this is the sort of raw topology information. But you can see now that as a developer coding to this, the developer doesn't need to know that much about BGP. They just need to know about links and nodes and a bit about graph theory. And what you'll find is these fields like link ID, source, destination with their destination nodes and termination points, those are generic to any type of topology. So an OpenFlow topology will have those same fields. The values will be different, but the field names will be the same. It's only then when you come onto stuff like these IGP link attributes that you would see something that wouldn't be there for OpenFlow. But if you just want to draw a picture of the topology, all you need is these link IDs, source dest, node IDs, that sort of thing, and that's sufficient. And so this is where we start to see this value of abstraction coming in terms of topology and in terms of being able to do stuff that's that works across different protocols. And this is back to what I said earlier, the BGP model, BGPLS model, is back to what I was saying earlier, that we learn information about the network with a protocol like BGPLS, and then we use protocols like PSEP to program the network. So this is where you set up an LSP across the network. And again, that app that Bo mentioned, you can go in and see all the possible paths between two routers and then pick the one you want. And I mentioned this sort of, I showed you the link state rib and the link state topology, and all we have is a piece of code, this sort of topology exporter that just takes the rib and generates a topology from it. And then, as a user, you can access that topology. And so that's an example of where we have services inside OpenDaylight that aren't plugins per se. They're not talking to the outside world. They're just internal services that are generating data that we can use. One final thing I want to say about BGP is one, which is a bit of a segue to the next section, is that in XR we have our Yang model for BGP configuration, and that's been also generated from the XR schemas. The issue there is that's effectively proprietary to XR, and what you'll find in OpenDaylight is OpenDaylight also has its own schemas for BGP. What we want is to have a common one. Now, there's a group called OpenConfig, which was started up largely by Google, but also with involvement from British Telecom and one or two others, and they're defining Yang models for things like BGP, and so there's a standardized BGP Yang model they've developed. And in fact, both OpenDaylight and XR have now implemented that model. So you can use the same Yang models to configure two different systems. So finally, we're getting to that original goal of having standard data models across different platforms. And really, that's what I wanted to say next, that we had this picture of ODL accessing XR, but there are some challenges, and that's the first one. Standardization of models has been very slow. The IETF seems to be taking far too long. There seemed to be a lot of focus initially on platform configuration, things like configuring where my NTP server is, where really as service providers, we're much more concerned with how do I provision services for my users. And there's also been this issue of, because the IETF was taking so long, the OpenConfig group spun up, and now there's a bit of a sort of split between the two. The other challenge we get, as I mentioned, the XR models are also generated from our own config schemas. And then if you want to standardize models, you've got to figure out how to map from one to the other. I think in the longer term, you might find vendors going what I call Yang native. So the schemas of the device are based on standardized models, but for now, we don't have that. And what we really want to get to is to say, well, we've got these device layer models that we've also generated in XR, but what we want is a layer of standardized models on that. But even that isn't really enough. What we want to do is work with the network as an abstraction, so that's where we have these topology models. But then, in fact, at the top layer, what we really want is service layer models and intent-based models. I mentioned intent earlier in the context of ACI. But, to give you some real examples of this, so if I'm provisioning a layer 2 VPN, I've got models on the Cisco device. What I really want are standardized models from IETF or whoever for things like the interface and layer 2 VPNs. But then I want a network-wide version of that that can say, this is what a layer 2 VPN looks like. But then for my end-to-end service, actually I might well be looking at somebody like the MEF, the Metro Ethernet Forum, to standardize this is what an E-line or an ELAN looks like, regardless of whether it's being configured on an MPLS network or an optical network or anything else. And the same might be true on intent, that, really where I want to get to is I don't want to be saying, back to my OpenFlow example of saying, well, you can access effectively the TCAMs in a device. I don't want to be going to each device in my network and saying, block this microflow. What I want to be doing is having an intent-based model where I say, I've got a DDoS attack coming into my network. This is the range of ports, this is the range of IP addresses, whatever it is. Just stop this across my whole network. And we want to operate at that kind of intent-based level. And I think the key to get there is going to be this topology abstraction. So this model that I showed earlier with link state, where you've just got a list of nodes and a list of links, that we're finally getting that to RFC, though we've sort of battling through the last bits of politics to get that done. And really, you have a list of nodes and a list of links, and nodes have termination points that let you have multiple interfaces on a node. A key thing is it lets you do topology layering, so you can say, well, this link or node in this topology depends on that link or node in that topology. So you can imagine the classic, I have a layer 3 network based on a layer 1 network, and I can see the relationships. But as I mentioned, one of the critical things here is that you can use the same model for many different protocols. So you can map protocol-specific information into your identifiers, but then you can augment models, as I showed with link state, for additional information that you have from your protocols. That then gets you to this point where you can write code that doesn't have to care whether it's dealing with OpenFlow or optics or IP. A systems developer can just think in terms of topology in a very protocol-neutral way. And the way we do a lot of that is that we take those base models and then we augment them, which is the Yang term. So effectively, we specialize them. So we say we have a network topology, and we then specialize that into a layer 3 topology, which again we can further specialize into, for example, OSPF or ISIF. And so as a developer, if I only care about basic topology, I can talk to the topology model. But if I'm doing anything routing related, but I'm not specific to ISS or OSPF, I can talk to that intermediate layer 3 unicast topology model. So it gives you that sort of flexibility to be as specific or as generic as you want. So finally, I think, so we mentioned, I think earlier, a lot of what we were mentioning earlier, and I guess this was to Bo's question, was about, what about stuff that isn't just configuration? And a lot of what we discussed was configuration. And so, yes, in the BGP section, we're starting to talk about other things, but how do we really address things that are the rest of FCAPS, for those of us who remember network management and the, fault configuration, accounting, performance, and security? So, in the SNMP world, that was what we used SNMP for, but, really we want to move away from that. But particularly what I think we want to do is move away from this polling model. And the reason for that is because there's so much operational data in the network because of the number of counters in ASICs these days. And they say that imitation is the sincerest form of flattery. Well, I don't think you can beat theft. And I wanted to draw this picture, and then I realized somebody had already drawn it. They just happened to work for my biggest competitor. So I stole this Juniper diagram here showing really the model we're looking for, where instead of SNMP polling, where you'll talk to the routing engine, which will then talk to the line card and bring the data back, ultimately where we want to get to is the line cards just exporting that data directly. And that data can be of two types. It could be time series data. So for example, every 5 minutes you send more, you send your link counters or flow counters. But it's also event-based data, so links going up and down, that sort of thing, routing events, etc. And really where we want to get to is that we pump that data out through a message bus, such as Apache Kafka, and then it goes into effectively a giant data lake where different applications can act on it. And again, coming back to this picture we had earlier, the question is, well, okay, how do we act on it? And I guess that's where I'd contend, again, an SDN controller like OpenDaylight will come in. So having decided, you've collected all this data from your network, you've seen that there's a problem. So, for example, you've found there's a DDoS attack going on. And to come back to that intent example with DDoS, your application probably doesn't want to have to know the details of how do I configure ACLs on every router in my network. What you probably want is an intent-based API on something like OpenDaylight, where you can say, okay, here's the characteristics of this DDoS attack. Will you, the controller, go off and stop that attack? And so really that's the sort of final step in this, that we pull data out of the network. We use something like a message bus to distribute the data. I mentioned earlier this Panda platform, which is a pnda.io, which is an open sourced analytics platform. And again, as with controllers, where Cisco also has ACI, in the analytics space, we also have the titration analytics, which is to ACI as Panda is to OpenDaylight, I guess. And then, having the tricky part, and this, I guess, is where I hand wave about artificial intelligence and machine learning. The tricky part is how you figure out from that data that you have a DDoS attack going on, and then, ask the controller to do what's necessary to stop it. So I guess that's the end of the slides I had. I think we're still okay for time. So if people want to, to ask other questions, then by all means, go ahead and ask. And I know I plugged it already, but if you want to dive deeper into specific areas, certainly on the BGP piece, I've got a lot of material up there, either through DevNet or just up there on YouTube from ODL Summits, etc. I think what you'll find, particularly the ODL Summit stuff, is there's a whole bunch of other materials. So, if you're interested in OpenFlow, for example, there'll be talks on that. whichever your specific area of interest in the controller is, you should be able to find that specific information. Whereas, as I mentioned earlier, I'm very much more focused on NetConf Yang and on BGP. And that really comes, I guess, from being a Cisco guy, I guess. So I'm being from an SP background, I'm very much focused on that, those sort of very SP-related protocols. But as I say, there's a lot more to OpenDaylight than that, and sometimes it's a bit like the elephant, and the blind men, that we all see it slightly differently because perhaps we interact with different parts of it. And I know, I have one colleague driving a whole lot of work on using OpenDaylight for the Internet of Things, and that's something, really that I don't interact with at all, but it's out there. So yeah, far away.
Well, one of the things you might be thinking about to advise us on is a possible speaker for Panda. That sounds like an interesting technology. Chris and I were sitting here talking about that, and so that may be a topic for us in a future talk. Also, I was able to get a hold of Santiago, so I think next month Santiago is going to present on his YDK toolkit, which is a Python toolkit to make use of REST and Yang data models that are in the devices. He's got something that will actually take the data models out of a device and convert that into a whole list of Python libraries that you can easily use to extract and manipulate the data directly in the routers, and I think that's very exciting too. It's a great follow-up to some of the stuff that Giles was talking about. So,
yeah, and in fact, there's actually an intersection. So I was looking at some of the YDK stuff the other day, and they support direct NetConf and RESTCONF access to devices, but they also support what they call OpenDaylight mode, where effectively they're doing what I was showing earlier. So effectively, in that instance, your YDK is talking RESTConf to ODL, and then ODL is talking NetConf to network elements. And yeah, it's all Yang driven, so there's a lot of interaction there.
Chris, did you have something?
Yeah, I was just going to say, so normally we have a Q&A session, and then after the presentation's over, folks are able to come up and talk to the presenter one-on-one. Unless you have, a fast track to London, you may not be able to catch him after this. He's probably going to go to bed because it's about 2 in the morning. So, I'm anticipating some questions here. I'm sure that folks have them. Go ahead and fire away. We'll control it with, raise your hand or, go ahead.
So, with traditional CLI access, we have tools like TACAX to control accounting of who does what. Are there any tools like that built into OpenDaylight?
Yeah, so there is a whole sort of AAA model that's in NetConf. I mean, at this point within OpenDaylight, it's pretty bare bones, and I guess some of that's what I was speaking to earlier, that we really need to get to the point where you don't just know that the controller modified a router. You need to know which user or which application on that controller did it. I'll say there is some stuff there on OpenDaylight. There's a AAA project within ODL. I'm not the expert on that one, but I would assume over time it'll get richer. Because we all know the same operational issues apply. Just because we've left CLI doesn't mean we don't still need to know who did what.
So I'll ask the standard. Giles, you will be sending us your slide deck so that we can post those online.
Yeah, for sure. And actually, to the point about interacting with the presenter, while yes, it's true that I probably need to go to bed soon. Equally, I do have an email address, so if people want to sort of send, one-to-one questions, that's easily arranged.
Yep.
I can probably put the email address on the presentation. That might be the easiest.
Yep, that will work. And we will have that posted to the user group page so folks can access it there. Any other questions folks want to go ahead and shoot at him while he's still here and still coherent in real time?
How does the OpenDaylight stuff interact with security or like voice solutions?
Sorry, what's the last bit about security or?
Or voice solutions, the various voice products and whatnot?
Oh, okay. I guess at this point, as I said earlier, in many ways, ODL's kind of a toolkit for developing network applications. So, I'm not aware of any specific work with voice, but there's no reason it couldn't be done. So, as I mentioned, there has been some work on IoT. In the same context, in ODL, you could do stuff around voice. I mean, exactly what you would do, I'm not sure. I mean, so for example, you could implement the whole sort of SIP signaling thing in ODL if you wanted. I guess the question then is, you know, where the benefit would be and whether that's the right approach. But certainly, you know, given how generic it is, it's certainly something that could be done if there was the demand.
Sure.
Can you make the screen bigger?
I'm sorry, you want to make?
We can't see that email address.
That'll be posted. Yeah.
Hey, Giles, are you going to be at ONS Summit?
I'm afraid not. Actually, yeah, I'm not sure when I'm next over your side of the pond, and I'm not sure I'm particularly looking forward to the immigration when I get there. But on the plus side, my current passport's a lot better than the old one. The old one had stamps from countries in that might have raised suspicions. So I'm glad my new one's a lot cleaner in that respect. But yeah, although remind me when is ONS?
In April.
Yeah, so I may be over that way at that kind of time. So I might try and get down there. Though I know at some point in April I've got there's a MEF event in Frankfurt that I need to get to. But I certainly would anticipate being in the States in the next couple of months. So I guess I get to meet those nice immigration people. But I will. Yeah, I'll see about ONS. There was also, I know some of the other work we've been involved in ODL, there were people talking about meeting at ONS, weren't there? So it might be worth getting over.
I think there's not going to be an Open Daylight Summit this year. So I think the advisory group may actually have their only chance for face-to-face at ONS Summit. So that's why I've got my bid in to go. So hopefully I see you there. Any other questions? Well, Giles, thank you so much. It's been a pleasure to have you. Thanks for staying up really late. I owe you an adult beverage of your choice next time I get to see you. And
sounds good to me.
We extend our thanks very much for your time.
Thanks, guys.
So we'll let you sign off. We're gonna pass the tin around and draw for prizes here.